Hi everybody, I'm back, ready to work a little bit more on area and perimeter. Got a little bit of an explanation with the videos I made yesterday, went through kind of what the formulas were. I shared with you a formula sheet that these formulas should be on. And so I wanted to make a video of just me going through a few different kinds of problems having to do with area and how we might solve those, okay? So first let's take a look at what I gave you. Here they are, sorry. Okay, here's the formula sheet. So there's the 5 shapes we're talking about today: triangle, rectangle, trapezoid, parallelogram, and a circle, as well as the formulas. Okay, so you're only worried about the top of this sheet right now. So have that handy or write them down somewhere. And let's work on some problems. Okay, so which one is this? No. Okay, let's start with this one: area of mixed shapes. So these are just some basic shapes. One of the 5 that we have listed here in the formula sheet. I'm not going to go through the rectangles with you because that was in the last video. Rectangles, squares, length times width. It can't get much easier. Okay, so then let's just start here on number 1. Let's take a look at that. It's a circle. So remember, when we're talking about a circle, when you find the formula for area of a circle is pi times the radius squared. And so you have to know what the radius of a circle is. Radius of a circle is what we actually see here in this picture. Goes from the center to the edge of the circle. The other way to measure a circle is from edge to edge, all the way across. That's called the diameter. But we're not looking for the diameter, we're looking for the radius, since that's what our formula is asking for. Okay, so the radius is 6. If you want to write your formula down, the area of a circle is pi r squared. In the video yesterday, we talked about what pi is. Remember, it's just a number. If you have a pi button on your calculator, which you probably do, let me pull up my calculator. Let's see if pi's on there. Yep, here it is. So move me out of the way here. If I hit pi, the pi button, notice it gives me a long number for pi. If you want to just use the first 3 numbers, 3.14, you're welcome to do that. That's the general consensus on pi, but using the pi button on your calculator is going to give you a more accurate answer, okay? But what you need to know is different worksheets use different numbers for pi. It could be 3.1, a long one, as is we see in the calculator. So you have to kind of adjust when you see your answer is a little bit different than what the worksheet might say. Okay, and maybe that'll come up. We'll see. I'm going to use the pi button on here and just see what kind of answer we come up with. So back to the circle. Circle. Radius is 6. So pi times the radius squared. So I'm going to use the pi button. So rather than write 3.14, I'm going to put pi times 6. And it's radius squared, so 6 squared. So I'm going to take this and I'm going to put it in my calculator exactly like that. Pi times 6 squared. So let's go to calculator. There's pi. Start fresh. Pi times 6 squared equals 113.097. I didn't look at what the directions told us to. It just says find the area of each figure, okay? So let's round that to 113.1. And again, that's with me using the pi button. Had I used 3.14, let's see what we would have got. 3.14 times 6 squared equals 113.04. Okay, which if we rounded that, it would just be 113, or it could be 113.04, depending on what you were rounding to. Now let's check what the answer says for this one. Oh, the answer for this is 36 pi. So one thing that's probably good to talk about, since I sent you this worksheet, is this worksheet does not even multiply out past pi. They just did radius squared, 6 squared times pi. 36 times pi is how they have their answer listed, okay? But if you want to know if that would have been the same thing that you got, then all you got to do is do 36 times pi on your calculator. Should be what you got, okay? Let's go back up to the first page. Skip 2, 3, and 4. Number 5 is a circle, okay? So why don't you take a second, pause the video, and work this problem out. We're going to come up with the actual answer instead of what they have there. Should have gotten pi times 16, which is going to give you roughly 50.27. Let's see what we're talking about here. That's in feet. Okay, don't forget when we're talking about area, it's always square units. So even though we're measuring the circle, how much space is in the circle, it's still square feet, square footage. How many square feet would fit in that circle? And, you know, it's not a real neat and pretty thing. Partial boxes, partial squares here, but that's the magic of pi. Pi takes care of all that, okay? So the answer to that would be 50.27 square feet for number 5. All right, let's take a look at the next one. Okay, it is a triangle. Okay. So why don't you pause the screen, try and find the area of that triangle. Okay, then come back. Okay, now that you're back, let's take a look at this. It's triangle. So what you should have done is first went to your formula sheet, unless you already have these memorized. To find the area of a triangle, you're going to do 1/2 times the base times the height. You remember what I talked about yesterday? Whenever your formula has base and height, those two dimensions must hit each other at 90 degrees. Okay, that's kind of your indicator whether that's your base and your height. So we can see the 90-degree angle. Base is 8, height is 8. So 1/2 times the base of 8 times the height of 8. So we're going to do 1/2 times 8 times 8. Now, one thing you may or may not know or remember about multiplication is you can do it in any order. I can start by multiplying the 1/8 times 8, or I could start with multiplying the 8 times 8. Doesn't matter. As long as I multiply the three numbers together, I'm going to get the same result, same product. So I'm just going to start here. 1/2 times 8. Half of 8 is 4. Multiply that times my second 8 to get a total of 32 square centimeters in that triangle. Okay? You could have started with 8 times 8, which is 64. Half of 64, still 32. Okay, hopefully you got that one right. Let's go back to our worksheets. There's another triangle. Base times height. 10 times 5 is 50. Cut it in half, 25. Number 7 is going to be 25 square yards. I think you can probably do the rest of these. No trapezoids on there. Let's go to the other one. All right, here's the other area, mixed shapes. Starts with a trapezoid, okay? So if you want, go ahead and try this one. Remember, go to your formula sheet, write down the formula, and then fill it in with your information, okay? From there, you're just gonna work out the problem. So give it a try, pause your screen, and then come back and watch how it's worked out. Okay, here we are. So if you remember what a trapezoid is a shape that has two bases or lines, sides that are parallel to each other. But then the other two sides, so it's a quadrilateral, the other two sides are not parallel with each other, okay? So the other two sides are going in different directions while one set of sides is going the exact same direction. That's what makes a trapezoid a trapezoid. So when you look up the formula, 1/2 base 1 plus base 2 times the height. 1/2 times the quantity of the base 1 plus base 2 times the height. So fill it in. 1/2 comes down. Base 1, remember our two bases are our parallel lines, parallel sides, 4 meters and 9 meters. Doesn't matter where they go, because we're going to add them together. So that makes the height. Remember, the height is going to be at a 90-degree angle with the base. So 6. So we're going to do 1/2 times, don't need the meters in there, sorry, 4 plus 9 times 6. So order of operations says we must do the parentheses first. 4 plus 9 is 13. So I'm doing 1/2 times 13 times 6. You know what? In this case, I think I'm going to multiply these two numbers together, 1/2 times 6, because that's easy. That's 3. Cutting 13 in half is going to give me a decimal. So 3 times, bring down the 13, 3 times 13 is 39. So the area of that trapezoid is 39 square meters. Parallelogram seems like it might be difficult, but if you think about what it actually is doing here, let's take a look at that a little closer. Okay, look at this part here that that we see to the left of the dotted line. What I want you to imagine is that's like a puzzle piece, okay? And if we were to actually cut that off, it would go over and fit right here. Let's see if I can make this. Oh, no, okay. Sorry. It would actually fit right here in this corner. And if it did, what that would make is a rectangle, all right? So when you look at the formula for a parallelogram, the formula is base times height, which is the same thing as length times width. And that's the formula for a rectangle. So parallelograms really are rectangles. They've kind of just, I like to say they've been blown over one way or another, but it's still the same amount of space inside of it. Okay, base times height must hit at 90 degrees. 4 times 5 is 20 square feet. All right.